Ladies and gentlemen, welcome to my class. Today's topic is topics in analytic geometry. Okay, we're going to first talk about parabola. Okay, what is a parabola? So let's first consider a point and a straight line. Okay, so we want to find what points are equidistant. What points are equidistant to the given point. I'm going to call it P, and the straight line. I'm going to call it L. Okay, so as you can see that this point, right, is equidistant, right, to this and to this line. It seems to me that this point, right, and this point, and this point, and maybe a point here, a point there. So it appears that this point form what? A curve, right? This curve is called a parabola. Okay? So this is a parabola. A parabola. Okay? Now we want to find the equation. Okay? What is the equation? Of this parabola. All right? So we want to find the equation. Okay? This is a geometry problem, and we deal with it analytically, right? Using the equation. Okay? So we can first set up a coordinate system so that the equation looks the simplest. Okay? We first set up a coordinate system so that the equation is the simplest. So how can we set up the coordinate system? XY coordinate system. So obviously, we can make use of this point and this straight line. So we draw a perpendicular line from the point to the line. Alright? And then extend to the other side. Alright? That's the x-axis. Okay? And how can we pick the y-axis? So we can pick through that point the middle point, because this middle point is equidistant, right? Equidistant to the point and to the line. So we make use of that point and we draw vertical line. Alright? Now we have a XY coordinate system with origin O there. Okay? So, we want to find equation. What is the equation of the parabola? Oh, parabola. Parabola. Okay? So, to find equation, we need to pick any point on the curve. Okay? Any point. And we denote this point as Q with x, y coordinates. Right? So by definition, this point is equidistant to this point and to the line. Do you agree with me? So we draw distance. That's the distance between 2 points. And we draw distance from a point to the vertical line. Alright? So we call this point R right here. So this is R. Alright? So now P QP equal QR. Okay? So this is the definition. What points are equidistant to the given point P and the straight line L? Okay? So Q is one of those points. So we find the distance. What is PQ? QP equals, we use the distance between 2 points. But the coordinates of this point is clear, right? What about this? And this one is fixed. We know this, right? We know this actually, okay? Because P and vertical line are given. So the distance between P and the vertical line is known, right? That is known. And this is halfway between. So we can assume that this point, okay, the P point, the coordinate, we can simply call what? Small p, 0, okay? Don't confuse with the big P, the point, okay? So small p, 0, that means this origin, this is P, okay? Small p. So the distance between QP is x minus P, y minus 0. That's the familiar distance formula between 2 points. Now let's calculate QR. What is QR? So this is perpendicular to the vertical line. And we know that the distance is equal to this plus that, right? And we know this distance is just what? This, because this is rectangle, and this is just P. I said O is the midpoint of this and this. So this part is just the distance is p, right? P. Keep in mind here p is positive, okay? And this is what? X coordinate, right? X. X plus p. Very simple. Now, we plug these two in the equation. What we get here? So we get square root x minus p squared plus y minus 0 squared equals x plus p. And this is the equation. It involves xy and p is given, xy are variables. So how can we simplify this equation? Take square root on both sides, right? To get rid of square root. Okay, we square both sides. We get x minus p. Well, then we further expand the two square term. X squared minus 2px plus p squared plus y squared equals x squared plus 2px plus p squared. So we can further simplify by canceling common terms from both sides. So x squared term cancel. X squared term cancel. P term cancel. And we combine collected like terms. So we got y squared equals 4px. That's the equation of the parabola. And this is one of the standard forms of parabola. Okay? So a parabola may take another standard form, and this one is one of them. So this equation corresponds to the coordinate system set up like that. Okay. So let's take a break.